Okay, so let's talk about parallax occlusion. And we're going to talk about also its predecessor, which is bump mapping. So, what parallax occlusion and bump mapping are is essentially they both are the usage of height maps in conjunction with a normal map. So, normally you would have, like if I threw any one of these materials on here, like let's just throw that, like this detail one. If there was no lighting to this scene, or if the lighting was very dark or very harsh, it would be very hard to pick up normal information because normal maps naturally need um, a light component in order to work. Because what normal map basically is it's showing. Um, Let me go to one of the textures. So the normal map has three different light vectors built into the channels. So you have one. Let me show you. So it has one viewing from the side, one viewing from the top, and then one viewing from, in a sense, above, or in a sense, this is like your Z's. So this is your the depth. So this is how far it's supposed to go in to out. So you have all three of these built in conjunction to kind of figure out how this object will be lit from every different angle using these three different directions. But in other cases where the lighting isn't that good, or maybe you're working in a project that doesn't pertain lighting, there are other ways to kind of create that effect, also using the normal map. So the first one is bump mapping. So let me create a new material first and show you guys. So we'll just do bump map or bump offset, or I believe it's bump offset is what they call it inside of Unreal Engine. And then I'm just gonna go and hop in here. And let me also grab I put it in the textures folder by accident, but that's fine. Let me grab the normal base texture. So I'm gonna grab a couple of these things to make it easier, because essentially you only need you only need the basics for this one. Okay, so we'll keep all these ones, we'll keep the tiling, we'll keep the normal map and the strength. I don't need masking per se on this one. So let's go in here and just start plugging some of these guys in. Oh yeah, forgot. O R, and then I'll turn this guy off and just do the normal one, because in most cases we're going to be using non-metallic dielectric materials anyways. So first thing we're going to do is we're going to do our right click and type in bump. So it's going to be bump offset. This is the essential node to use for bump offsetting. Uh, Compared to parallax occlusion and then tessellation and displacement, bump offset usually is the cheapest, but is also the most limited to materials. So let me go and plug in our tiling for the coordinate, and then we need to bring in a height map. So I've already created, go to our textures. I've already created another base texture in here. It's essentially the base albedo, but I've turned into grayscale. Um, and the other compression settings, you don't have to change anything else. You don't have to do displacement or vector displacement, because displacement naturally is for the raw height maps that you would use. So, like if this was like a grayscale type of map that has different gradations, if I hit displacement map, it would basically just crunch all those details down, because it's basically turning into this linearized map. So just keep it a grayscale, turn off sRGB, and then we'll just bring that one in for our bump offset material. So you can do that, or you can even plug in the red channel as well. And then you don't have to worry about plugging in a UV coordinate to it because when this comes in, it's going to handle the coordinating from inside of this node. And then, of course, your last one would be creating a parameter for your bump height, or in this case, offsetting. And you'll see what I mean when when it says offsetting. So we'll go now in here, and you have to plug all of this into your UVs. Um, you also don't have to do a single texture as like in case for this. Maybe if you are doing a different kind of channel packing where you have height information in it, all you would need to do is duplicate this parameter, but don't change anything. So, like, say if you copy and paste and then plug in like the green channel to it, essentially it would only reference this texture twice or once, essentially, because in the instance, if you don't change the parameter, it won't. It will just use the same parameterization. So if in the instance material, if you change like what texture goes in here, it'll propagate in both of these nodes. So that's only if you're using that. So you can't just do plug this into the UV and then plug the height into there because it creates a weird logic loop, and we don't want that. So let me just go in here, group it for height, and then let me also change this guy to parameter. Also, yeah, make sure when you're also bringing them in to by default, if you bring this texture in and it's already set as grayscale, it will use linear grayscale as default. So he's just going to be called height, and I'm just going to bring him towards the textures, and then these guys will stay the same. So let's hit save and apply, and then let me create an instance of the material. There we go. Bump offset. I'll just call this one cobblestone. I'm at, or actually no, a cobblestone bump. I'm at, and I'll bring in these cobblestone textures that I already have made. Albedo, ORM, normal, and height. And essentially, what I did with the height is, um, I grabbed this material from inside of Megascans, but by default, some of these height maps are just very flat. You're not going to get that much definition of certain areas. So, like, I wanted to have more of the stone areas to rise up a little bit more. So I brought it into Designer and then just did an auto levels to break out a lot of these like higher shapes, and then I just adjusted a blend between the two to get a value of both of them. But the other thing to make sure is when you're bringing in like a displacement map or a height map, which those names are just displacement, height, and bump are essentially the same thing. Bump was they called it the bump map because when you first started using it, it was not inside of video games. It was essentially inside of what was it called? It was essentially inside of animation. So they called it bump because that was their way of describing what the attribute would do. It would make bumps on surfaces. So now let's go in here, and we have everything all set up. So I'll hit save. And then I'm going to show you guys kind of essentially what it's going to do. So say this is our flat surface. What it's going to do is this will be like our top of mesh. It's going to essentially do is it's going to use that height information to help kind of offset some of the normal values a bit to try and make it appear deeper than it actually is, even though it's going to be a flat surface. So it's trying to use the height map to create this depth value based off of certain angles. So let me bring this guy back down. Go back. There we go. So we'll go right here. Oh, let me close that. Let's go. Of course. Yes, hit save. Hit save on that one. Okay. So let's go and drag in and let's take a look. Higher screen. So this guy, you don't need to put too much value to. It's very finicky, so it's like point like 3 or even point 0.4. Actually, no, let me also plug in the height. We'd have a problem if that didn't work. There we go. So you actually will start to notice a little bit with when I start to move. It's adjusting the offset of the depth to kind of give off this shape. So if I could do like point 0.4 or 0.4, and if I look at it from like this angle, you'll see that it's actually kind of creating a height to it, but it's only offsetting the texture a little bit within some fake depth. It's like point 0.03 maybe. And then this is what it looks like when it's completely flat. So the essential thing is, in most cases, you won't be looking at your surfaces like from that close up. Because if you get really, really close up, you'll kind of see the weird artifacting that kind of comes with this effect. So like from here, from like this angle, it looks really good. The only essential problems you would have is because it's not changing the actual mesh itself, it's just kind of coming off as this kind of flat shape. So you wouldn't want something like this to be very noticeable. It's gonna kind of really break the effect. But this essentially is the cheapest option. It's just creating a simple offset. Whereas let me go and duplicate the bump offset master, and we're going to create a POM or parallax occlusion map. So parallax occlusion mapping is similar in the way it's implemented using like a height map, but it's a lot more expensive because what it does is instead of just simply offsetting as best as it can, like with this guy, where um, here when you go into the instance and you kind of crank it up as high as you can, it can't figure out how far the depth is supposed to go, and it starts creating this weird blurring effect with the normal map. Because what it's doing is it can't actually adjust the normal map. It's just using it as a mask. It's not creating an actual displacement of the depth. So it's creating this very weird effect because it can't handle such extreme angles. So after a certain point, like right here, is when it just gives up. So it's only used. Oh no, 3.03. So it's only to be used like sparingly on small surfaces. Whereas here, let's go and change some implementations for it. So we're gonna cut this guy. We're gonna right click and we're gonna type in parallax. And I'm gonna show you also why they also call it parallax occlusion too. Okay, so now let's start plugging some things in. So let's plug in our UVs. We're gonna have to convert this parameter now into a. Actually, I can't convert it, but let me go make a texture object. It requires a texture object, base, height. There we go. Height. Let's plug him in. And essentially, we're only going to need these top areas. These are for controlling different aspects of light. Um, in case you have like a custom lighting setup. In a lot of people's cases in certain games, if they're trying to come up with their own type of lighting system that is not kind of packaged in with Unreal Engine, they're gonna have a hard time with parallax occlusion. So this is where you would come in. You can adjust like how penumbras are affected on light surfaces, and then same thing with the light vector values and stuff. So we're gonna go now to here, and we're just gonna change this to like offset height, and we're gonna plug that there. We're gonna plug him there, and then next thing we need to do is gonna plug in this 4 vector, and then we're just gonna set the red channel to 1. And what's gonna happen is you have to plug it into here because it needs to reference what channel is gonna be used for this guy. So since by default it's like a grayscale texture, it's gonna need the red channel. So that's why we plugged that one in. And then there are 3 other parameters that we're gonna need. First is gonna be what we call steps. So first is min steps, and by default, let's set that to like 8. And then the other is max steps, and we'll set him to like 64. That's kind of high, but it's just going to show off the effect a bit. And then our last one is our reference plane. So I'm going to change that to plane height. So we're going to leave that at 0, plug this one in, and plug this one in. And then the next thing is we're going to start plugging in our parallax UVs. Okay. And that should be pretty much it for this guy. So let me go about, I'm going to show you guys side by side of this. So let me go and grab the parallax material, wherever it is, and then create an instance, cobblestone, POM, I'm at. And now let's plug in all of our textures. Oh, wrong one. There we go. Okay. So out of the box, nothing really has changed as of yet. So let's start by adjusting our height a little bit. So let's do offset height. We'll set him to 0.03. And as you can see, we already have really good definition of everything. Um you also notice that it looks like it's kind of creating a weird height value and it's clipping because of that's how far the mesh goes. This is that parallax occlusion idea. So what the idea is that this mesh has two effects. Parallaxing, which um let me change the where is it at? Let me change the plane height and show you guys. So I start moving around, you'll see that the plane kind of moves a little bit. Like, do you see that every time I move, the plane kind of moves at like a different speed? Like the angles are off a bit. That's parallaxing. It's kind of like in those old cartoons when a cartoon character would run and then the background would move in the opposite direction, and then there's like some bushes or trees that's kind of moving in a similar direction as the character, but they're all moving at different speeds to kind of show like movement better and add depth to a scene. That's what this kind of is. So it's parallaxing the actual mesh. So we're actually seeing like it, but it's like lower into the ground than it looks. Like here's where our actual height is because this is like where the mesh is, but from here it actually looks like it's further down and steeper. And that's when you would adjust this plane height to kind of figure out where you want it to land. The second part is this thing called occlusion, which it's not like ambient occlusion where it's defining where the object occludes light or shadows light in a sense. What it's doing is it knows that you're going to see this guy at many different like extreme angles, so it's going to try and occlude actual parts of the object. So like if our height map was like really really strong where it's going to have certain areas like really high but then really flat peaks, it will actually occlude technically this geometry, even though technically if we go to like lighting only it's just a flat surface. Let me hit detail lighting. No, not detail lighting. Which one would be not lighting only, not detail lighting? Unlit. Oh yeah, unlit. Here we go. So unlit still shows it. This is what I was telling you about, to still keep that definition of the normal information. Whereas, like, if we didn't have this, you still wouldn't see this definition still. Like, it still looks like you see height definition on it. Same thing with this guy. But the only other problem is that you have to try and figure out the height to match this guy, and then it still looks weird because he's kind of floating but invisibly on there. And that's something that we can actually change. So first, let me go about the other two things that we created, which are steps. Let me change this guy's height to like 0.5 maybe. So now he's closer up. But you can start to see that we have these like really weird like banding lines. And that's what these steps are. So what the parallax occlusion mapping is doing is it's kind of slicing up the height map into different layers, and it's adjusting of course like where things go in and go out. It's creating these fake offsetted layers, whereas using normal bump mapping only creates one thing and it tries to just stretch it out. This is creating a fake amount of layers so that it can define the shape more. So like if I do 16 instead of 8, you start to get more definition, even like 32. And then I do like 128 for him. You can see that like I can make the his height strength really strong or flat, but it still has a lot more definition than say this guy does. And then he can of course have his height adjusted a bit more. So let's do 0.75. Let's do zero point 0.5. There we go. So we're kind of close to the height a bit on him. Let's do 0.25 maybe. Yeah, there we go. Now we're like at a surface close enough for him. Again, but we still have that problem where it looks flat. And we can actually fix that. So it's kind of going to create this weird sense of depth, even though the geometry is not going to change, but it's going to fake depth and actually make it seem like it's an actual piece of mesh. And that is this feature right here, which is pixel depth offset. So it's basically saying that it's going to use the information from like parallax occlusion, so like the height map and the null map, and actually occlude and cut out the areas where the flat mesh that we're using for the material and the box is, and make it seem like there's actually geometry there, even though it's still just flat geo. So what we do is we can plug it into here into this guy straight and hit apply and save. And you can actually see it's, it's of course having some depth issues here and there, and that's where you have to kind of fine tune it a bit more. So let me go back here, but you can actually see that it's actually shaping around these like cobblestones. So it actually creates this effect better. So let me go back to this guy, change our plane height a bit more. And then let me change his height a bit more. Like that, actually. That's pretty good. And of course, like, viewing it from this angle, you can actually see the cutouts a bit better. 0.5 maybe. So it's actually creating this shape, defining around it. So that actually helps out a lot. Um, you can also actually move this guy a bit and actually see how it's looking like when you start plugging him in. So like you can actually blend some different types of materials. Like maybe instead of creating cobblestone, you can actually do like make your own custom mesh of like like coins or something, and then have it masked out like only this area has the coins, and then you can actually adjust like the mesh itself so it's like an actual like rounded shape, like a sphere kind of like this. And then you can make it seem like there's actual coin piles, and then it's actually cutting out parts where like maybe this is in dirt, so like there's certain coins sticking out of the dirt. Um or something, even though again, this is just a flat mesh and it's still not even no, that's detail lighting only. There we go. Okay, lighting only, that actually looks good. So it's not even actually it's still a little bit above the ground, but it's not fully there. But it's again creating this fake depth. Like if I do 0.04, it pushes the depth down a bit more. But again, we can actually see that it's actually trying to figure out the depth of the height versus the depth of the floor plane itself. So it actually helps with blending. Like if you really wanted to try, you can blend it like this and then maybe have like triplanar painting around it to kind of shape a bit better. But for the most part, it looks really good. It looks, you know, essentially like it's actually trying to blend together. And of course it will try to do the same thing here as well. Like if I so it's not just between like one interaction, it's with as many interactions as it can. But again, it's gonna be expensive. So be very wary of when you're playing around with this stuff because it has to project and handle a lot of these kinds of features. But this is like not as expensive as say like tessellation and displacement is because it's still just we're still rendering the geo, but it's using a lot of extra effects in post processing to handle the depth and lighting of this type of material. And then of course, like if you really want to kind of go in there, maybe um, you can actually apply another blend type. So like this will be parameter PDO depth. Oh, and then just plug that in there, and then plug that guy in there, and then hit the changes, and then you can actually go into PDO depth, and you can see how it's flat right now. So if you can actually go in, you can actually do like 0.5, and maybe have it as a subtle amount of depth and not a lot, or you can do one. Actually, I did one on the plane height, not the actual PDO. You can do one, or you can do like five, which again, it's all basing it off of depth value. So it's trying to figure out where, in a sense, this guy's supposed to end versus the height information for this guy. So try not to do extreme values. And again, it's only for at like certain viewing angles for it. So this is not to be used for something that needs to be viewed close up. So this would be great for like a floor if you have like a third person player like walking around. So like let me set up like that, set him up like that, and then hit save, and then just hit play, and then just kind of walk around a bit. So again, you also got to realize too is your height for your the pixel depth offset. Like from here, it doesn't look bad, but if you look like here, it still kind of has this weird issue where it's trying to figure out what the depth of the height of the parallax effect, and then you can also adjust the height a little bit more, like messing around with this plane number. Like you can bring the plane height uh actually higher than it's supposed to be. You can actually see that it's actually doing this weird effect. If you actually go and play this, um, it tries to figure out where the player's feet are, and in some cases, it actually will make the player's feet kind of show up like it's cutting through the rocks, but the collision is still lower. So you're gonna have, of course, like these weird graphical issues. Let's see if I can find the proper. Let's try 0. Try that height maybe. Oh yeah, I forgot the collision. So yeah, be very careful when you start applying this stuff around, just because you have to remember, especially in games, context for whatever the perspective is what counts. So try and fine tune your tweaks on this guy because you also got to make sure that like the parallax isn't as floaty like this guy because you can actually see like subtly that the floor is kind of moving in a weird way around him. Like there's a jitter, almost like it's like disconnected. That's when you would have to adjust some things like his height offset and the plane offset and just figure out where those kinds of values come from. But that is essentially um, parallax occlusion and bump mapping.